find the electronegativity. Welcome to the lesson. Today, we will be learning how to classify bond types according to electronegativity differences. Please be aware, we will not be introducing the concept of chemical bonds, nor will we be defining electronegativity. We will simply be using this periodic table of electronegativity values and using these values to find differences, meaning one value subtracted from the other value, and using that resultant in order to identify the nature of the chemical bond. For our first example, let's consider the potential bond between hydrogen and chlorine. So here we see that the first element that we are looking up on our table is chlorine, and we see that it has an electronegativity value of 3.2. Next, we find the electronegativity value for hydrogen, which comes in at 2.2. Simply find the difference between these two values, and you find that it is in fact 1.0. That electronegativity difference of 1.0 puts this bond in the category of polar covalent. Now that we know that hydrogen and chlorine are going to form a polar covalent bond, let's model what that looks like in terms of the actual bond. We see that hydrogen and chlorine are truly bonded together, but because chlorine is more electronegative than the hydrogen, hydrogen's electron will still truly spend more time closer to chlorine as compared to hydrogen. These two electrons involved in the bond truly belong to both chlorine and hydrogen. Electrons involved in the bond spend more time around chlorine than hydrogen. Next example, let's consider the potential bond between an oxygen atom and a chlorine atom. Again, taking a quick peek at our periodic table of electronegativity values, we see that oxygen has a value of 3.4, and chlorine has a value of 3.2, just like last time. Let's subtract one from the other, and 0.2, which puts this bond squarely in the realm of non-polar covalent. Now that we know that oxygen and chlorine are going to create a non-polar covalent bond, we can move on to describe how the electrons will be shared within the bond. Because the electronegativity values of these two elements are so similar, we can conclude that the two electrons that are in the bond itself will spend essentially the same amount of time around each of the bonded atoms. While it is true that oxygen has ever so slightly a higher electronegativity value compared to chlorine, it is not significant enough to make the bonded pair of electrons spend more time around oxygen when compared to chlorine. For our final example, let's consider the potential bond between sodium and sulfur. Again, going back to the periodic table with electronegativity values printed for you so that you do not have to memorize them, we see that sulfur has a value of 2.6, while sodium has a value of 0.9. Subtract one from the other and we get 1.5. An electronegativity difference of 1.5 puts us squarely in the realm of ionic bond. Now that we understand At this point, with this reference table available to you, you should be able to classify bond types by electronegativity differences.